So now let's talk about randomness and how it is perceived in video games and how differently it can be perceived in video games. So first of all, since the philosophical conference, let's ask a big question: what is randomness? So here I generated a nice random pattern that you can generate in many places online. And so what is the definition of randomness? Well, one definition that we can use for our purposes is that it's a lack of predictable patterns. So the point is that you see something and you cannot really predict its future states, for example. And the other definition that might initially look different, but it's interesting because it ties randomness with computers, is this. Random string is a string that is shorter than any procedure which can generate it. And this is a definition created by Kolmogorov and Hyatin, and it's currently, I think, the best definition of randomness there is. And interestingly, it actually says the same if you think of it. But because if you think, what does it really mean that a given string is shorter than a computer program that is generated it? What it means is that there are no ways of compressing this thing. So it's basically, there's no way of compressing this thing, and you can't basically find any patterns to compress this thing. And you have to have something bigger than the procedure to generate it. So this is what randomness is. And so, of course, another big problem, it's also a philosophical problem, is can randomness appear in a computer game? It's a bigger problem I ask about computer game, but we may actually ask if randomness can actually appear in computers at all. And this is a question that is often asked. And to answer this question, we have to realize that randomness in games evolved from simple random generators that we use in board games. And we still use them in board games. But of course, in computers, they are much more complex and also generate this problem, because some people might say, okay, dice are really random, but if you use virtual dice, it's not really random because it's algorithmic, so how can it be random? So, in order to understand how it works, we should differentiate between true and pseudo-randomness. So, what is pseudo-randomness is that your computer may use an algorithm that uses some kind of data that is available to it, and then give you a random number. So, a classic example would be, and this is what typically computers do, is computer takes, for example, a number of seconds it's on. So this is a number that computer can take, filter it through some algorithms, maybe add some other aspects of itself, and then generate a random number. And this kind of procedure is called pseudo-randomness. Why? Because it's not really random, because in every possible situation, if you repeat the same situation, you will get the same number. So it's not really random. So of course people want real randomness for computers. And how do they get it? Well, they get it from the world. So this is why I gave it this lava lamp here, because lava lamp is actually one popular way of getting randomness in computers. You just put a real lava lamp, then you film it, and you use this data to create randomness. So you basically get the randomness from the world. And this is how it's done right now. And it's very easy to do. You can you can just go to a website. I hope it will work, because we had some. Okay, so this is a nice website that creates real randomness for you. So this is a coin cost with 2 coins that is really random, because it's getting from basically weather reports. So again, if you're creating a game, you can just plug into this, use a very simple random generator that is available to you, or have a hardware random generator, and you have true randomness in games. And that doesn't get more random than this, because if you want to question that this is true randomness, you can do that, but you would have to question that there is randomness in the world. But it's a different problem. If you don't believe that there is randomness in the world, well, you don't believe in randomness anywhere. So It's not a problem anyway. So again, so to answer this question bluntly, yes, we can have true randomness in games quite easily right now. But we also should differentiate between randomness used to create a game in creation and randomness that appears in games. There are many games that use randomness in the creation process, but they don't really have randomness inside them or have very little randomness inside them. So here's a screenshot of Just Cause 2, and the map of Just Cause 2 was generated randomly or procedurally. I will go into the difference later. But the game itself doesn't contain any much random elements in it, so it's not anything special. So today I'll be focusing mostly about games which contain randomness in it. Not that we created using random procedures, but that contain randomness in it. But also, you might ask, should randomness appear in a computer game? Is it a good idea? Right? So, well, to answer this, it's useful to realize that for some video games or some computer games, randomness is basically the epitome of bad design. They should be just like these meticulously crafted machines that you skillfully operate. They should be perfect. If you are good, there should be no problems generated by randomness. Look at this guy playing Guitar Hero on 150% seconds. I mean, let's imagine that you introduce randomness to his performance. Of course, it wouldn't be possible. But so games like this basically cannot have random elements. If they have, it's called a bad design or a glitch or something like this. But on the other hand, you have games in which random element is absolutely necessary. If you, for example, go to any of the popular casino pages, and let's say that we play a roulette right now, and but not for real, I didn't put any money in it. So let's go. Let's see. What can I say? Fortunately, I didn't put money in it. And if I do this, I have to assume that there is a real random generator on the side of the server. If I didn't, I wouldn't play this game. Because the whole point of it is that I have to believe that the game is not rigged. So in some games, the true randomness has to be there. In some games, it just can't be there. But in most cases are somewhere in between. They contain random elements, but they also have to be these skillful machines. So let me just ask another question. Why exactly people use randomness in games? And there are two important reasons for this. First reason is that it gives replayability. This is a screenshot of a YouTuber who has a clip of him playing The Binding of Isaac, and it's a clip number 807, and all of them took like 40 or an hour, and he just can, he could go on and on forever. It's not obviously so. Randomness gives, if it's done right, it gives you infinite replayability, which is an important point. And the other thing is that, of course, randomness gives us pleasure. It's a pleasurable thing. And why is it pleasurable? Well, let me just quickly summarize how it works. Why randomness gives us pleasure. Of course, we, just as rats, are pattern seekers. And we want to see patterns in everything. So whenever something happens and we get a reward, whenever something nice happens to us, but it's completely random, it looks random for our brain, the brain wants to find the pattern. But how can the brain find the pattern? The brain is a statistical machine. So in order for the brain to find the pattern, the brain has to force me to repeat the same situation many times, because my brain wants to have a nice statistical sample to find the pattern. And how my brain can trick me or force me to doing something? Well, it has to just give me pleasure. And then I will do it again, because this is how our brains get statistical data. So it is pleasurable and we can't change it. This is our evolution, just as the rat's evolution. So Now, the thing that I wanted to talk the most is that there are two phases of randomness in games, especially now from this point, whatever I said up to this point is more general. Whatever I'm going to say from this point on is very specific to the current trends in games. So in current trends in games, there are two phases of randomness, and I find it fascinating that the same thing, the same phenomenon, randomness, can be seen from so different perspectives. So the first, which I call the dark side, is basically the loot boxes idea. So the fact that many contemporary games contain random mechanisms and, combining real money purchases with random rewards mechanisms made players question if gaming became gaming. I won't be focusing on this dark side during this talk because there is a published paper, so if you are interested, just look it up. It's in Digra, this year's Digra. But there are 2 points of this paper that I want to mention right now. First of all, it is important that loot boxes, that is the epitome of randomness, they trigger the same cognitive mechanisms as gambling. So this is important. First of all, what loot boxes do to people is that they trigger the mechanism of, and this is the most important mechanism from the point of view of this talk, the false belief that the fact that I was losing so many times, I didn't get items I wanted, gives me more probability of getting them in the future, which is called gambler's fallacy, and we all know it, that there is such a fallacy, and loot boxes give people the same feeling. This is very important. But what is more important is that game developers reinforce this fallacy, because they create something called pity timers. What is pity timer? Well, pity timer is an algorithm that messes with randomness in the game in such a way that if you are unsuccessful and you get bad loot, basically, for like 50 times in a row, the game will just give you good loot as a reward, because the developers don't want you to go away from the game. But if you think of it, this reinforces this false belief that probability works like this. That I was losing so much that now I will win. This is pretty risky, and that's why people are very unhappy about it. Well, one of the reasons. As I said, I'm not focusing on this part of the dark side because there is a paper about it. I just want to focus now on the light side. So the light side is basically procedural generation. Procedural generation, which is, as I will point out in a sec, universally praised, and it's very, very popular right now. So this is a screenshot of Frontier Elite 2, one of the early procedural generated games which contained like whole universe. And I remember reading the interview with the main designer, who said, and interestingly, this game was designed and published when CD-ROM started to be the new thing, and he was boasting, these people just put 650 megs of data on their disks, and I have one floppy disk with the whole universe on it. This is basically the idea of procedural generation that is fascinating to people, and I'll be talking about it. So, a quick aside, what is the difference between procedural generation and randomness? So the big difference is that the idea of procedural generation is that something is done via an algorithm instead of doing it manually. So instead of, for example, drawing a picture, you create an algorithm that draws a picture for you. And importantly, procedural generation does not have to have random elements. It's not something that is necessarily connected. If you look at a classic game on the ZX Spectrum, The Hobbit. Well, if you look at it. So this is procedural generated graphics. But there's no randomness in these graphics. It's just procedurally generated graphics. And basically, the idea is that, of course, the game contains randomness in different elements, but not in the aspect of graphics. So it is important to remember that I'm not going to conflate procedural generation with randomness, but having said that, they are oftentimes connected with each other. Right. So they are typically connected via a notion of seed. That is, what you have is that you have a procedurally generated game in which there is a random element called seed that puts values into variables in the procedure. So this is a screenshot of Binding of Isaac, and you get the seed in this red square, and what you can do is that you can write down the seed, and whenever you play it again, you will have the same procedure, because the same starting values will be in place. So it's also the idea of procedural generation with randomness can be likened to the idea of possible worlds, but I don't have time to go into this. We can do it during the Q&A session. So let me just point out why procedural generation is so popular. First of all, it's basically right now it's almost universally praised. There are some people who are unhappy with this or fed up with this common trend, but it is very popular still. And it starts to be used in multiple genres. So I would say that from outside that we are living in an era of procedural generations. If you look like this extremely popular games, all of them are procedural generated. Minecraft, Spelunky, Isaac, and so on. So No Man's Sky, of course. So this is like just new games, right? And so what are the reasons why procedural generation is so popular in games? There are practical reasons and philosophical reasons. I'll just go through practical quickly because they are easier and focus on philosophical. So first of all, procedural generations creates a synergy of different factors. First of all, the current production methods of indie games is very well suited for procedural generations. You can have 5 or 6 people and have a huge game for many, many hours. Second of all, it is compliant with many popular genres, such as survival games, roguelikes, or Metroidvanias. These games are very well suited for this type of procedures. And it's compliant with the newest forms of marketing. Think of Twitch. Twitch is a perfect platform for promoting a procedurally generated game, because the nature of Twitch is that people tune in and out. They don't watch the whole thing. They watch the narrative games on Twitch are much harder to watch. But if it's something procedurally generated, it doesn't matter if I tune in the first hour, on a 7th hour, on a 10th hour, or tomorrow. It doesn't matter. So these games are perfect for streaming. And also it's compliant with the iterative model of games. So if you have a game that just goes forever, you can just add to it. It's not a problem because people will never stop playing their game. But there are also philosophical reasons for popularity of procedural generations, and they I think might be more interesting to you. So first of all, procedural generation is the promise of a fully autonomous art. Art without intention or reference. There's no intention. There's no intention that leads to what happens in the game, because it was just generated by a procedure or a random seed. And there is no reference because it can be generated just completely out of the blue. It's not taken from the world. It's just generated inside. So it's an autonomous product. So if you take the classic example, is Winston Churchill's face made by ants his portrait? People might say, no, it's not his portrait. But if you ask, is a lake generated by a computer a lake? I would say, yes, of course it's a lake, because you can drown in it. So it's a perfect lake. I mean, Minecraft lakes are lakes, why not? So, of course, virtual lakes, but it's another matter. So also procedural generation enables the players to discover new structure. It gives you a sense of discovery. If you play Minecraft and you see something, you are the discoverer of this world. This is basically the idea behind the No Man's Sky. And it creates gravitas, as the thing the player experiences may never happen again. So if I play something and I have a good run in something, I might feel that this is my moment. Maybe this is the only moment in my life where I will finish the game. So it gives emotions. And it liberates the player from meta-analysis. You don't have to think, why did they put this element here? Well, it's random. You don't have to think. You're free from thinking about it. And it promises design without responsibility. If I find this swastika in Minecraft and it is procedure generated, who do I sue? Mojang? The algorithm? So there's no really a point. So, well, let me just conclude with this. Yeah, thanks.
So that's a short question now. Why exactly is the procedural generated lake a lake when the essential space is not a space? I didn't grasp that.
Sure. My point is this, that If you have a picture and it's generated totally randomly, people might say, well, it's not a picture because there's no intention behind it. And when you have something generated in Minecraft and it works, in a sense that it has a dedicated function. If I have just a picture generated in Minecraft, that might be not a picture. But if I have a lake in the Minecraft or a mountain in a Minecraft, the fact that the machine and the computer is able to interpret it and say, okay, so you will down here, you can't go here. So it changes its nature because it's real for you. You can't say that, oh yeah, it's just.
So the idea is that it somehow reacts to the player's actions?
Yes.
Oh, okay.
Yes.
I'll just start without the microphone. Thank you very much for a super interesting presentation. I think the final slide here may be what is most interesting to us now here at the
that's what I planned.
But I'd like to contest your argument that procedural generation or procedural content generation is authorship without intention and without reference. Take an overanalyzed scheme like Passage, for example, that's often analyzed in relation to Jason Grover's creator statement, that's very much considered art in relation to the discussion of art games. That has procedural content generation at its levels.
Yeah, I mean, the short answer is that, as I pointed out on a slide, it is a promise of that. So if you don't want to use this promise, you don't have to. You can create the very strong authorship over a game that uses some elements of procedural generation. But at the end of the day, if you look at the thing like this, Angelina,
yes,
which is
I wanted to mention.
So I would say that at this point, it's kind of Angelina is an AI which creates games. So these are all games created by AI, and the descriptions of games are also created by AI. We don't have the time to run it, but at this point, I would say that this intention is so far from the creator that maybe not there.
But Angelina is still a code designed by someone.
Yes, of course.
So there's still that possibility of approaching it from.
There is a possibility, but I'm just saying that there is also a possibility. The only thing I'm just saying on the slide that there is a promise of breaking this, of saying, okay, I'm an author, but I created an autonomous work that lives and creates itself. So that's my point. Back.
Thanks for your presentation. I have a question that is more very on the ontological level, because I think you have fascinating issues in this procedural generation topic. So I don't know if you recall that I think Grant Avinar has a passage in his book where it says that we wouldn't want to say that every player, even if two players have different playings of the same video game, we cannot say that they are playing different games, or you want to find a criterion to identify different playings, even if they are qualitatively different. So when you take procedural generation, you have an issue which is interesting. You could say, for take No Man's Sky, you could say, well, on the one hand, you have one game that is No Man's Sky, you can buy it, and if you buy it and I buy it, we are buying the same game. It's the same work type. But at the same time, since our universes will be completely different, and even if you replay the game several times, it will be completely different. You could say that these games are not works by themselves, but rather work generators, or they are producing different instances of, you have two things. Say either it's a type that produces different tokens, or you can say that the tokens themselves contains different types. So my question is, perhaps you could add that to the philosophical reasons for popularity.
Thanks. You're right, absolutely. But you answered the question actually. So I would say we've said games are types that have tokens, and every token is instantiated when you open a machine. So when I start the machine, I have a token of this type. I would go with this. I think this might be somehow counterintuitive, but it generates less ontological problems. So this is my solution to this. But when it comes to procedural generation, I would say that it would be nice to add the additional framework of possible worlds. I think that they are best analyzed through possible worlds.
Maybe I can just shout, I have a loud voice. Whatever.
Thank you for the great presentation.
I really like the slide with practical reasons for randomness and for procedural generation in games. There's a debate that is very hot between game designers even now, and that is whether true randomness is actually a good thing from a practical standpoint. Basically, I've heard a lot of game designers with 10 years of experience and more tell me that the players do not believe that the result of a random procedure is random if it is true randomness. Basically, a truly random process can give you 10 ones on a dice in a row, and then the player thinks, oh, there has to be something wrong with their random number generator. It's not random. And so they tamper with randomness in more than one way, in more than just tampering with these loot boxes by Peter timers, but they make it sort of more interesting by, as they think, more pleasing by tampering with it. So what's your take on it? Is it ethical? Is it unethical?
My take on it, it's an aesthetical argument, because it's very much similar to the problem that people which id Software had with Doom. There was a nice interview when they say, so we made the shotgun sound realistic, nobody liked it. We just changed it, and we just boosted the sound and changed it. People say, how realistic this is. So this is exactly the same. People praise something as realistic because it's just fun for them, but it doesn't have to be. Yeah. So I think it's an aesthetical issue.
Want to go to the far side?
Could you elaborate the claim that it liberates the player from meta-analysis?
Yeah.
To me, it just shifts you to a different kind of, instead of thinking what was the developer.
Yeah, I'll be very happy to, because I had to go through it quickly. So, I mean, for me, it's a oftentimes irritating tension, and it breaks the fun of games. That my brain starts to look for patterns, and I start to think about what do developers want from me here? Why did they put this building here? It has to have some meaning. Maybe it's a red herring, but it's really, and so on. And this is something. I mean, you might like it, and it's fine. But sometimes I feel kind of burdened by it. And procedure generation, I just walk through Minecraft vistas, and I see something. Oh, it looks cool, and I don't have to ask why is it there. There is no why, and I find it very liberating.
Can I go on?
Yeah. Very quickly, please.
Thanks, yeah. It's just I'm thinking in, for instance, No Man's Sky, instead of thinking what was the developer thinking, thinking why are the parameters of this procedurally generated alien dinosaur set so narrow that it looks just like the last one? It's just a different...
Yeah, because it's badly made. It is badly made. Creatures are badly made. Vistas are okayish, but creatures are simply very badly made. You very quickly see, okay, so this is just a combination of this torso and different legs and stuff like that. But if it's really well made, and I believe what I see, in a sense that I see very different things, I might feel liberated from any thinking about any intention behind it. And that's something intriguing, I think.
Okay, let's thank Pavel.
Yeah, thanks.